quantity is a measurable attribute of an object, and we were looking at this truck. We named attributes of the truck. We named measurable ones and ones that weren't measurable. The ones that we can measure are the quantities, and then we looked at the soil. And in the reading, you saw that for a given object and situation, some quantities may be changing, and some quantities would be constant in the given situation relative to that object. So that's what we want to talk about now. Changing versus constant quantities. So here's our truck. So the truck bed starts to lift. And the first bit of dirt hits the ground. And then the truck starts to pull forward. And then all the dirt is out. Okay? So question for you is, here are some quantities. They're all time quantities. So I want you to decide if they are changing. There's 5 time quantities there. Decide if each one, if it's a changing time quantity or a constant time quantity. So, for instance, to look at this video and say, I want to consider the quantity of time, would mean really very little, because there's lots of different ways, lots of different quantities that are all time quantities. So here's 5 examples, and I want you to decide which are constant and which are changing, and you can discuss with those, or think about it yourself, and then maybe compare with the person next to you. Okay, go. So which are changing and which are constant? Okay, have a conversation with the person next to you. Compare.
Besides the time, all the time, those are like the time around 1 second, 3 seconds, or so that's like the time spent.
That was I don't know. Yeah. I didn't know. The second one I sent you. I didn't.
It makes sense to me.
Different trucks are sort of different. Yeah. Time truck fits and yeah, that's right. I didn't do this one. I put that change because it depends on the time lapse. Yeah, it is depends on like there's friction. Yeah, there's no. And then time elapsed from when to begin again is constant. And then I did that.
Okay, how about the first one, the time elapsed since the soil first hits the ground? Is that a changing quantity or a constant quantity? Changing, because when that soil first hits, time equals 0, and then time starts to go. So, and we're measuring the time since the soil hit the ground. So that could be 1 second later, that could be 5 seconds later, that could be a minute later, right? Okay, how about the time elapsed for all the soil to be dumped? Changing or constant? People are saying, oh, we got both.
Well, at what point are you asking about quantity? Are you asking after all the soil has been dumped, or are you asking like as it starts, the time that it takes for it to all be dumped?
The time that it takes for it all to be dumped.
So if these are all quantities of time, wouldn't they all either be changing or constant depending on how you define it? If the quantity is time every single time, then they all have to be changing. Time is always changing.
Can this, number 2, the question is, can that take on multiple values, or is there one amount of time that takes? That's the question. Does that help? So is it changing or constant? Is there one amount of time that takes, or could it take on many values? Imagine watching the video over and over again. In that situation,
It's a constant value because it's the total time needed for all the soil to dump at the rate at which it's moving up.
she says constant. Agreed? Yeah.
It's the fact that there's an endpoint for it that makes it constant.
Okay, that's part of it. Sure. It is constant. Every time we watch that video, it's going to take the same amount of time from when the soil starts to be dumped to when it ends. That's a constant quantity. It's a fixed number of time. Does it make sense? Okay. How about the time the truck bed spends moving, i.e. tilting upward? Constant. Every time you watch the video, it's going to take the same amount of time to tilt up. Okay? The time elapsed after the truck begins to pull forward. That's changing. Because it could be 1 second since it began to pull forward. It could be 10 seconds since it began to pull forward. It could be 2 minutes since it began to pull forward. Do you see it? Time elapsed from when the video begins to when the truck bed starts to tilt. Constant. Questions? Is this making sense? End of the tunnel? Just going for the pass. Look out. And then exiting the tunnel.
Left.
Okay. Watch it again. Because now it's going to be your turn to make up quantities. He's going to win this time. Come on, you can do it. Dang it. Beat him again.
Left.
Okay, here's your task. I want you to come up with, I'll keep rolling it. I want you to come up with 3 constant distance quantities and 3 changing distance quantities and 3 constant time quantities and 3 changing time quantities. And you can work with someone else. Okay? We want the kind of specificity that I had in the dump truck example. So you need to really be specific. So 3 changing distance, 3 constant distance quantities. 3 changing time quantities, 3 constant time quantities. Watch it again.
Left.
Yeah. I'm doing this.
Distance between the two runners. That and then constant the distance spent in time.
Okay, so let's do distance first, and what I'm gonna have you offer them up. But when you offer it up, don't tell us if you think it's changing or constant, and we'll see what the whole class thinks. So who wants to just offer one of your distance quantities? Don't say if it's changing or constant. Yeah.
The length of the tunnel, or whatever it is.
Distance from the beginning to the end of the tunnel.
Yes.
Is it a valid quantity? Is it constant or changing? Constant. Good. Okay. Yes. Distance between the runners. Is it a valid quantity? Changing or constant? Good. Another one. You had your hand up over here, someone. Distance run by the, just pick one. Women since start of the video. Since video starts. Valid quantity? Changing or constant? Oh, I heard both. So the distance run since the start of the video. Now I'm hearing. Oh, I'm hearing. So we have a fight on our hands.
I'm gonna say that it's constant because every time, just like the truck, every time you watch the video, she's still gonna run the same distance, like from start to finish.
Okay. So you're saying from the start of the video to the end of the video.
Yeah, there's no.
Okay.
Changing because it doesn't specify a time in the video.
Okay.
This said ran, this would be constant.
Yeah. So could she run a meter since the video start? Is there a time? Could she have run a meter? 10 meters. 30 feet. Yep. So there's many different values that quantity can take on. That's a changing quantity. How about one more distance? Yeah.
It may be invalid, but the length of the stride.
Distance of the man's stride. Changing or constant? Changing. Yeah, it's good. Yeah, so the stride will change. It'll be about the same, but if we're going to be precise, it'll definitely be different on different strides. Getting the hang of this? Okay. Time. Same thing. Just so throw out, so let's have some new ones. Throw it out there, but don't tell us, and we'll, how about someone new? Go ahead. Yellow shirt.
Time lapse from the beginning of video to when the runners realize that they haven't turned left.
Okay. Time from beginning of the video to point of confusion. Changing or constant? Every time you watch that video, that amount of time will be the same. Yes, ma'am. Time elapsed since which one?
Since the passing the man.
Women past the man. Changing or constant? Changing, that's right. Somebody new. Give me another one. That's a changing. Yeah. Time elapsed. Who? Which one? How about the man? Valid quantity? Changing or constant? changing quantity. How about one more? Yeah.
Time the woman spent in the tunnel.
Good. Valid quantity? Yes. Changing or constant? Constant. Okay, good. Any questions on this? So, really important that when you're talking about a quantity in this situation, the moral of the story here is you got to be very specific. Just to talk about distance in that quantity really means nothing. So we could come up with 10 more distance pretty easily, and then if we worked at it, probably 10 more after that. And then same with time quantities. Okay? Okay, so now that we've talked pretty thoroughly about quantities, what we like to have for changing quantities is we define variables. Okay? For varying quantities, we often assign a variable, a letter, and here's what it represents. Any or all values that that quantity could take on. The fact that it's changing means it can take on many values, and so we put the letter there to say that letter could represent any of the values that that quantity could take on. So when we define a variable, we want to make sure that we do that well. Okay, so how do we define a variable well? There's 3 criteria. The first thing is we want to make sure that we're defining a quantity and not just stating an object, right? A equals apples. Is it valid? No, because it's not a quantity. Apples is the object. So A equals, what's a valid quantity? Number of apples. What else? Okay, so that size of the apples gets on to the next one. The next thing is, you got to be fully specific. What do you mean by size? There's different ways to measure the size of something. Volume, okay? So A equals the volume of the apples. Or A equals the weight of the apples. Those are 2 different quantities. So, and this is what we were working on just now when we were talking about the distance and time. So you got to be fully specific. And then the last criteria is you got to have units. Defining a quantity itself doesn't need units. That's what we've been doing so far. We just said distance or the time. But if you're going to define a variable, now you're talking about the values, the numerical values that it could take on. And so you can't be specific about those values unless you know what unit you're talking about. Okay? So the quantity itself is just the description. It's the specific description. Since we're not talking about specific values yet, it doesn't require units, but a variable does. Because a variable is actually takes on numerical values of that quantity, so you need to know what those units are. So all throughout the course, when you start problems, starting the problem often will mean understanding the situation and defining variables. And you want to practice doing it well using these three criteria. So just quickly going back to this. So now if we want to change these quantities to variables, we could say D1. So how is this? Is this a good? Oh, so variables. So we can use variables to represent constants. Okay, that's perfectly legitimate. We can call a constant value some letter. But we want to focus on the changing quantities. So the first one I think was this distance between the runners. I think it's the second time it shouldn't do it, but it's doing it every time now.
All you have to do is move the mouse over.
Stop it. There we go. Okay. So how about this? Is this a well-defined quantity? D1 equals the distance between the runners. Why not? No units. Is it specific enough? Sure. So in what unit do we want? Meters. Now we got a variable. Now we've well defined this variable D1, the distance between the runners in meters. At different times, that D1 has a different value. So that's why we use a variable for it, because it can take on many values. Okay? How about this one? Distance of the man's stride. Well defined? Nope. Because we need in inches. Okay, so go back to these four, find the changing quantities, and assign variables for the changing quantities of the time ones that we picked. Go. First one, changing or constant? Constant. Second one? We'll call it T1. Is it specific enough?
No.
Okay, so it's specific. The description is specific enough. It's very clear what it is, but what's missing is the units. How about the next one, changing or constant? Call it T2. Or we can just, so you don't have to have a number after it. I was just keeping T for time. So just T. T equals the time elapsed since the man exited the tunnel. Again, we need units. Doesn't make sense. Why is this important? Because you get through a complicated process of working with these variables, solving a problem, and in the end, you get an answer, and if you haven't pinpointed what your variables stand for, then there may be confusion on the meaning of what you found. But if you start the problem by really defining well what your variables represent, then there's no question about it once you're trying to find a specific time after the man exited the tunnel. When you get that number, you'll know exactly what it means. Question in the back.
Yeah, when you put minutes, would it be appropriate to add the seconds as well, or would you have to specify that? Same with like distance. If you put feet, it would be inappropriate to put 5 feet 6 inches if you only put feet.
No, because if we put it in minutes, then we could have 3.8 minutes.
Okay, so
Or 3.92 minutes.
you would put the decimal of the minute, not.
Yeah, if it's in minutes, then you could have a decimal answer. Now, it wouldn't be incorrect then to change that to minutes and seconds. That'd be fine.
Okay.
It's still minutes. Yeah.
Is there a way to classify it so that you know to put minutes and seconds, or just say minutes and seconds?
Yeah, you could say in minutes and seconds. Yeah, sure. Okay, but if it's just minutes and we have a partial minute, we'll just use a decimal version instead of seconds. Okay, any questions? Okay, so what I want you to do is, in your workbook, look on page 22. I want you to read, we'll read this together. Number 2, page 22, number 2. A nurse was preparing a pain medication to administer to a 3-year-old child. The instructions say that the dosage is 3 parts pain medication to 2 parts water. Okay, the liquid pain medication is distributed in 4 milliliter pouches. Now look up to part C on the top of page 23. I want you to answer C and D. But here's the rule. You can't use cross multiplication. So if you've learned this technique in the past, that's not allowed. You need to use some kind of reasoning. So you need to come up with an answer based on a reason rather than that method of cross multiplication. Is it fair? Okay, so try C and D based on that description in number 2. No cross multiplication. So we want a reason for your answer rather than okay. So this should be able to do, without the cross multiplication and kind of track your thinking is how you came up with it. So 9 milliliters of pain med, how much water?
6.
Okay, so who can verbalize what happened in your brain to get the number 6? So one person, tell me.
Well, if it's a 3-to-2 ratio,
Okay.
if we have 9 milliliters of pain medication, to get to 9, we multiply 3 by 3, and then we multiply 2 by 3.
Okay, so you're saying what you saw was that 9 is 3 times as great as 3. Is that right?
Yeah.
And therefore, we need 3 times the amount of water.
Yeah.
That's valid reasoning. That's good. Anyone think of it a different way? Your brain did something different to get that 6. Yeah.
You said 3 is 1.5, or well, a 3-to-2 ratio is like doing 1.5 again as much.
Okay.
So, if you have 6, 1.5 again would be 9.
Okay.
Kind of did it backwards, but
So it's kind of like to get from 3 to 2, you say you're dividing by 1.5? Is that kind of what you said?
well, yeah.
So, yeah, so 2 is 1.5 times as much as 3, or 3 is 1.5 times as much as 2. So, what 1.5 times as much as what is 9? Okay, somebody else. Is there a different way that you thought of it to get the 6? Okay, so what we're embarking on here is proportionality. But as we learn about proportionality, cross multiplication is off the table. We want to understand it, okay? So in your reading, you're going to start discovering that there's actually 3 ways to reason when you have proportional quantities, okay? And these, we've kind of hit on 2 of them here, okay? So do your reading for Friday, and we'll start right at noon. We'll have our 2 questions. So be ready. Okay, see you then.
This should be